So my name is Gaurav from Nutanix. We were playing with getting high density VMs, high VM density on on KVM, and we discovered some interesting things about how we can squeeze more out of the host by tweaking the way cgroup's CPU reservation is done on KVM. This is not to criticize, this is just something to think about. It's a combination of the way libvirt sets up defaults and the way cgroup group scheduling is done in the Linux kernel. So I'll just put forth some things that we observed, and you could evaluate whether that helps you. So just very briefly, what is CPU cgroups? It's basically you set up a hierarchy of scheduling entities, and at the leaf nodes, you assign task IDs. And because of these weights that you've provided, the weights get portionally filtered down, and those are the reservations that are given to the tasks in the leaf nodes. And how does this work in libvirt? As probably a lot of you are familiar, and some of you coded that up. This is the default hierarchy, right? So if you look at how libvirt sets it up by default, it sets up a depth of 3 or 4, and then it sets up tasks for emulators and vCPUs separately, and it gives equal shares to everything. Now, just as an artifact of the way CPU shares works, the denominator is always changing, right? So if you add more VMs, more of these nodes get instantiated, and so you really can't do say absolute reservation for a VM. So that's kind of unfortunate. It's got nothing to do with libvirt. It's just an unfortunate way CPU shares works in the Linux operating system. And so what happens here is that if you do nothing, which is if you have never looked at this part of your configuration, this is relevant to you, because by default everything comes up with equal shares, and so the VMs are all equally weighted, irrespective of how many vCPUs they have. Something to think about if you haven't ever thought about it, right? So that's probably not what you want. That's probably not how to build a public cloud, for example, right? You would give VMs with no vCPUs higher shares. So that's something you want to keep in mind. And there's also no way to reason about the VM's reservations against the non-virtualization threads, which are not in this picture, because those end up in the root. And their weights, that's an interior node of the tree. And the way interior nodes are weighted is through nice levels. So it's very hard to reason about what really is going on between virtualization threads versus non-virtualization threads. So again, something you want to think through. If you don't have, if this gives you a picture about how intra-VM shares are set up, but not VM versus virtualization versus non-virtualization. And so the key takeaway is that implementing the way the Linux scheduler does CPU cgroups, not this picture, in general, is it has to run, the CFS scheduler has to pick a scheduling entity at every level of the tree. So the deeper your tree, the more work the scheduler has to do. And so that means that there is some serious overhead if you are interested in packing a lot of VMs. So just the final thought is, if you flatten this hierarchy, you might get 20 or 30% more VM density. And that may not be practical for you. For us, that extreme end of the spectrum was not practical, because we have a special VM that we need reservations for, but we simplified this hierarchy to get a big boost nonetheless. So just something you want to look at your configuration and see if it can help you. Thanks.